that was used in the 40s and the 50s by the military.
I have a question. What is the center frequency without modulation on the radio song transmitter?
403 megahertz and 1680 megahertz. They use two different frequencies.
They're both on simultaneously?
Huh?
They're both on simultaneously?
No, it's one or the other.
One for primary and one for secondary.
No, it's one transmitter or the other transmitter that's in the package. The early ones are on 403. The later ones,
exactly?
oh, plus or minus 2 megahertz. And the later ones are on 1680, plus or minus about 6 megahertz.
They were crystal tuned or?
No, they were just free running oscillators.
Free running oscillators.
The 400 megahertz, I was going to get into the details, the technical details, how the radio sound works. All right, this is a good time to go into that. I don't have any illustrative material, so I'll attempt to describe to you people how the circuitry works. It's a very unique system that they had. Essentially, the temperature element was a thermistor type. It is a negatively varying resistance with the temperature. As the resistance goes up, as the temperature goes up, the resistance goes down. Now, I had a mass spectrograph done on one of these thermistors, and I compared it to a YSI thermistor. And they both have carbon in them. They both are essentially carbon, but the radiophone thermistor had some silver in it, had some gold in it, had some platinum in it, had some iridium. I'm trying to remember the other two elements it had. It has a fair amount of silver in it. Silver was about 10% by weight. Now, for a thermistor, it's not going to make it any more accurate. If anything, it's going to make the curve go really strange. You placing it with metals like that. Of course, you read Wilhelm Reich literature, you'll find out Reich used sensors that had gold and silver in them. So that's one interesting note there. The humidity element is a plastic plate with silvered edges with a grid of conductive lines going across the plastic plate. This way and this way. This way, this way, this way, this way, this sort of thing. They put on a very odd mix of chemicals. The chemistry lab has not come back yet what the mix of chemicals is they put on it. Now, the unusual thing about the temperature and the humidity element is most electrolytic resistors I've ever seen, the resistance goes down as they get damp. These things, the resistance goes up as they get damp. Now, what we're theorizing at this point, which we've proven from the esoteric side, we have no physical data to back it up, is that the thermistor rod, the temperature sensor, the temperature rod, acts like an antenna for the door. It acts like a door antenna out of phase. That's the dead orgone. The humidity sensor acts as an antenna for the orgone. Of course, this parallels the whole idea of, you'll see in esoteric circles, people use salt water solutions with different electrodes in them to detect these energetics with a fair degree of success. Looks like here, Wright took it much further. Now, the pressure sensor is essentially what they call a barrow switch, or a pressure sensitive cycling switch. That the thing would rise, the pressure would change, and the needle in the little barometer would go across a switch segment, just the segment of a switch. That drove a relay that would in sequence put either the temperature or the humidity sensor back and forth. It would switch between these two sensors. And it would switch to, which I'll explain in a minute how it's done, to what they call a reference mode in the transmitter. So what they have, as this thing rises and goes above the earth, it transmits a signal that destroys the door, and also transmits a signal after that, or before, however you look at it, that builds up the orgone energy. Now, let's consider the transmitter. The transmitter is a very interesting little beast. It is two oscillators. An oscillator that runs at the carrier frequency of 403 megahertz or 1680 megahertz, There's a second oscillator, which is a 7 megahertz oscillator coupled into the grid of the carrier oscillator. Now, the control grid of the modulation oscillator, the 7 megahertz oscillator, has an RC network that causes to do the relaxation number. Now, as the oscillator runs, it builds up DC across the grid when the capacitor that's in the RC network for the relaxation oscillator. I have to apologize, I don't have any schematics with me. I didn't expect to talk of this, but there was interest at the table. As that capacitor will build up high enough in charge to put a high negative bias on the grid of the tube, cut the tube off, the oscillator will stop oscillating, of course. The RC network would discharge and pull the voltage down on the capacitor just like a neon bulb oscillator. So essentially that 7 megahertz oscillator would pulse on and off. Now, the lower the resistance, the faster the pulsing would be, and the higher resistance, the slower the pulsing would be. I'm trying to make this as clear as I can without having a schematic to point out. Are the two people here following what I'm saying that have some technical background? Now, they did not couple the 7 megahertz directly into the grid of the carrier oscillator. It couples into an RC network where the first resistor is in series with the plate coils. Between the B plus and the B plus end of the plate coil, they have a capacitor going to ground, a bypass capacitor that integrates the function. Then they RC couple with a series capacitor and a resistor going to ground on the oscillator of the carrier oscillator. But what happens, whenever the modulation oscillator would click in, turn on, it would cut off the carrier oscillator and shut it off. Of course, etheric signals are already differentiated, so it means when you put the differentiated signal through the integrated network, it comes out in its real form in that final amplifier, that final oscillator.
Wouldn't that circuit also attenuate the instantaneous spike? In other words, this is the emphasis network.
Yes. That's what
primary oscillator. That was the intent, wasn't it? Primary oscillator and the.
We don't know what the intent was behind it. That's what it appears to be. It's an integrator, which is the emphasis.
Right.
A differentiator is your emphasis network. You're thinking of. See, in engineering, as a technician, you talk of the emphasis and emphasis. In engineering, we talk of integration and differentiation. And being trained in that's what I talk of. So the etheric signal or the hyperspatial signal, the orgone is already differentiated. It can't do anything. It's 90 degrees out of phase to begin with. This integration network brings it back in phase for the transmitter to transmit it. Now, also, you have to keep in mind that when the tube goes from a semi-saturated mode, as it is when the carrier oscillator is oscillating the cutoff, there are other things taking place from the zero-point potential. When the tube is cut off, any of the etheric signal that's stored in the tube will be pushed out the antenna. Also, when you cut the tube off, and you go from saturation to cutoff, and from cutoff to saturation again, you're essentially ripping open the vacuum from the viewpoint of the Dirac space that he derived in the 30s. And you'll get an amplification. These transmitters only put out about a half a watt of CWRF power. The etheric content, or the non-real power, was equivalent to about a 250 watt transmitter. That's how efficient these little things were.
Can you describe the phase relationship between the RF output power and the etheric power and the frequency difference between the two?
Okay, the frequency should be the same. The phase relationship...
Would it be a cosine function?
Let's see, what would it be? It would have to be, let's see, we're coming out of the differential equation relating the baseband to the carrier frequency. It could be a tangent. Here's a tangent function.
So it would rise sharply
Yeah.
until the next cycle.
Mm-hmm.